Good morning, good evening, good afternoon. I'm Tiwari, 20BCE1018, and I'll give my DA1 presentation for cybersecurity. So the topic I am choosing is JWTs. That stands for JSON Web Tokens. So even before starting about JWTs, I'll start talking about what JWT came a replacement for, and that was sessions. So even before JWT came, the only way to authenticate and authorize a user was session. So how sessions work were, say that was a user, and say you are the user and you contacted a server saying that please authenticate me, these are my ID and pass. So the server will go back to the database and it will authenticate you, and after authenticating you, for authentication it will check a different database, of course. The authentication database is different and you cannot do it with this database, at least the auth. Now there is another database that is called sessions database, and in sessions database, essentially you're storing what all permissions does a user have, the current user has, and its session information. Basically this is the session information of that user, which can be seen something like UID. This is the user's ID for the current session, then what permission it has, and all the different session information that you want to store. Right now, okay, this is what sessions were, and the overhead that you can see here is the storage overhead in sessions database. Right, the authentication database is something that you cannot do away with. You have to store how a person is authenticated, what are the encrypted keys for that person. But for sessions database, this is what JWTs came as a replacement, because if you scale your server up, and then you realize that you have to store so many databases. So you have to take care of all the database paradigms like availability, consistency, everything, and you have to implement a load balancer between those as well if multiple servers are trying to access it, right? So there was a lot of infrastructure involved in uh, maintaining sessions. So JWT came as a replacement, right? So JWT stands for JSON Web Tokens, and as the name suggests, it is a token that is passed over the internet, that is whose data type is JSON. So for beginners, JSON is something like a key value pair, right? A lot of key value pairs, and JSON can be easily read by a lot of programming languages. So essentially, it's very easy to pass JSON, right? Now, what was done was, what now the current scenario was, say a user sends a request to the server saying that okay, I am this, since the ID pass again, saying please authenticate me. Right, now the server will of course contact the authentication database, right, the auth database. And apart from that, what the server will now do is server will issue a token, right, to the user directly. It will give back a token. So it's not storing anything with itself, it is giving user the token, the generated token. And there is no overhead of storing a different having a different database to store the user session. This JWT does everything. Right, now let's talk how JWTs are constructed. Now JWT has three portions or three parts, one of which is a header. So header contains something like what type of token it is, which for JWT of course is JWT, is JSON, and what is the algorithm you have used. Now we'll talk about algorithm later when we'll come to the signature. And the other part is a payload. Payload contains all the information about claims and expiry and other things that we want to add as well. So claims is what we call in authorization language as permissions. So in claims you can write that you have permission to view this database, read this database, write this database, or basically just a role that the backend of the server can disintegrate and give the required permissions. And the expiry that we talked about. So expiry is something like this token expires after 1 day. So after 1 day, if you receive the token, this token is no longer valid. You have to issue a new token and again sign in. Right. So we'll talk about expiry also. Now, the most essential part of a JWT is its signature. So, what signature is you take the header, you take the payload, you generate these two first, and then you take the algorithm that you pass along with the header and encrypt the complete binary binary sequence of header and payload with this algorithm and write it as a signature here, right here. So this is the complete JWT. Now signature is how the server can uh, make sure that the token is valid. So what it does is, so what JWT does is, what server can do is it can have a private key of its own, right? And using the private key, it can, yeah, sorry for the disturbance. Yeah, so we're talking about every server has a private key. So server has its own private key, and the signature that we get is after you encrypt the header and payload using this private key using the algorithm that you pass it. So algorithm can something like SHA 256, right? And you can then take your private key, right? The server stores the private key in its database. So the only thing that it has to maintain is this private key. Then you take the algorithm and encode the complete header and payload and write it as a signature. So every time you receive a JWT, you can re-encode header and payload and check if the signature is matching or not. So that's how you verify the JWT is valid, right? So this was the verification of JWT. Now we will talk something about expiry. So expiry is, as it sounds like, the common expiry time is a single day. So whenever you log into a website and say after some time you come and you see that you're logged out, right? So that's how, when your authentication token has expired and it asks you to reissue the token, right? So that's why it throws you out. Even in VTOP, like I think the VTOP's expiry time is something similar to like 15-20 minutes. So even after you come after 15-20 minutes, it'll just throw you out and say you have to re-log in or basically reissue your token, right? All right. So this is how JWTs work. Now, as you can see, there is no overhead for storing anything, right? Because the token itself is talks about it, everything, right? So it's stateless. This is what we call a stateless property, where the token itself is everything. So this token is not being stored anywhere, right? For user storing, for the user, this storing the single token is almost like no overhead, right? Because it's a single token. But for server, storing all the tokens would have been a very big overhead, like storing tokens of a million users, right? So essentially, this has no state, and you don't have to store it anywhere, right? But this poses a security threat as well. The threat is that if somebody gets access to this token, right, so they can impersonate the other person. So if X gets a token issued, right, and Y somehow gets access to it, Y can use the same token and impersonate X, right? Y can pass this token to a server and saying that, hey, I am X, give me all the permission that X has, right? This is a known flaw, and we'll talk about this. Apart from this, there were security flaws, and there were actually a lot of security flaws with JWTs. So we are not using JWT for very sensitive information, like the payload, right? Payload is open to everyone, right? If you have my JWT, you can easily see what my payload is, and if payload has something very sensitive, you can easily make a data piece out of it, right? So there were a lot of things done to fix this as well, like you can encode it with a symmetric key, right? You can have a public key along with this being passed, so you can exchange the public and public keys, have your own private keys, and then you can essentially encrypt the payload as well. So if you see, there are two encryptions happening. First, you're encrypting header and payload, right? And then again you're encrypting this into a signature. So that kind of made it very complicated, right? So it was then decided not to use this for sensitive information, but again, authorization authentication is itself very sensitive, right? So we'll talk about this problem now, where impersonation attacks were happening. So there was no mechanism to what we call revoke a JWT, right? The only way a JWT was revoked was if it expires, right? Which was a time, say 1 day or something. The other thing that usually never happened was the private key of the server changes. Right. If the private key of the server changes, the signature won't match. So it will say it's not valid. Right. So even right now, we don't have a very good revoking algorithm for this. And we are essentially relying on the transport layer security service to not let the breaching of JWTs happen, or a man in the middle attack for JWT, which can lead to identification theft and even compromise the database security as well. So for revocation, there have been a few solutions, but none of them have worked very flawlessly. So basically, I want to discuss about it. So first one is like setting a very small expiry time. Right now, although this might seem like a possible solution, but this can be very hectic, right? So if I have an expiry time of 1 minute, you realize what will happen. Like every time you're surfing the website, after every minute, it will ask you to log in, right? Or it will ask you to reissue the token. So that is a really bad user experience. If you are in something, say you're giving a contest on the website, right? And after every minute, it just throws you out. So that's not a really good user experience, and it might hurt your performance on the website as well. Another thing was a blacklisting of the token, right? Now, blacklisting, as it sounds, you can request the server to blacklist your token, right? So if X knows that Y is trying to impersonate X, X can just go to the server and say, hey, blacklist my token right now. Don't wait for the expiry. So the server will say, okay, and it has to maintain another database where it stores all the blacklisted tokens. Right. Now, as you can see, again, we have a database overhead, right? Similar to what we had in sessions. So it again boils down to the same problem that sessions was having. But one thing is that, say the vulnerability of this man in the middle attack for JWT is just 1%. So you are storing a lot less data than what sessions is trying to store. Plus, sessions has to store the complete list of claims and everything, but you are just storing the small token, right? Which although contains everything, but it's just a single field, right? Which is already compressed and encoded plus encrypted both. So this was a blacklisting, but again, you got another overhead of this, right? And also blacklisting relies on the user knowing that their JWT is compromised, right? So even this was something like after you know it's compromised, like damage has already been done. So even this was not very powerful, right? Now we'll discuss another solution, right? Which is a really good solution right now, but it's very hard to implement it. It's there's a solution. Let's not name it. Let's just define it directly. So in this solution, what happens is the server maintains different private keys for different group of currently active users. So say there are 100,000 active users in the website currently. So you maintain 100 keys, private keys for encrypting the JWT signatures. Right. So now what happens is every time a person in a group, so right now here as you can see every group is of 1,000 people. So every time a person in a group logs out, what you're doing is you're rotating the private key for that group itself. You rotate the key and reissue the JWTs to all the other users. Now again you can see a overhead here, right? The overhead is that you have to reissue the token again to all the users. So again, if the login and logouts are happening continuously, right? Not the logins, just the logouts are happening continuously. You have to reissue the token multiple times, right? And that has a very big overhead on the server side, very very big overhead. Like the encryption of the encryption in itself is such a heavy process, right? And every time issuing a JWT requires encryption as well as encoding. So every time a user logs out, you have to rotate the key for so many people, right? So that was a known problem, and it's a known overhead. Now, something other thing that can be done is say you take a very small group, say of 10 people, right? And then you're trying to rotate the keys for them. Then you might say that okay, just 10 people doesn't matter, but now just see how many different private keys that you have to maintain. You have to maintain 10,000 private keys, right? And keep rotating those and maintaining those. So even this has a database overhead, right? Maintaining the private keys on the server side. So either way, you have to find a very sweet spot of size of a single group where even the overhead is not so much, and even the maintaining of private keys is feasible. Right. So this is a known solution, but again, imagine maintaining so many groups over so many distributed servers, right? Even you will use distributed systems to host a single server, right? So maintaining different groups over this many distributed servers is already very complicated, but at least it ensures the security of the JWT, right? Every time someone logs out, no other user can log in back again using the same JWT because the private key is rotated. The signature won't be valid anymore, right? So this is how the revocation of JWT works, right? And JWT, even currently JWT relies a lot on transport layer security and other security measures of HTTPS, right? And that is how JWT is still alive, and JWT still works just for authorization, and that too in very few places to transport secure data, sensitive data. We use something called auth0 and auth1 right now, right? And these if I want to give a simple example of auth0, it's something like when you go to some website and you try to sign in, they offer you options like sign in with Gmail, sign in with Facebook, sign in with Twitter, something, right? So this is what basically auth0 and auth1. And again, even after this, you have even like there were breaches in auth0 as well. So they came up with OTP. So even after you sign in, mm, even after you sign in, they send you a OTP in your mail or phone number, depending on how they implement the security. And even after this was breached, they came up with timed OTP, right? So the OTP expires after say 30 seconds. But even this was breached, and then they came up with an authenticator OTP. So authenticator is basically an app that you can use, right? And it can keep rotating the OTPs. So basically, the even the server has to maintain the key, the private key that rotates the OTP for a user, right? And it can generate the OTP at will. Now on the back end, you can always compress this generation, like for a bunch of users, or you can hash the user into the private key and then generate a common OTP in the authenticator. So there is the overhead is just like with the authenticator that you have to generate. The server just has to verify it. So authenticator is a good practice in a lot of places. Like most of the enterprise level securities use authenticator for their users, their employees authentication. So that's all. I don't want to talk about this in detail. The main topic was our JWT and its revocation. And again, I'll just go summarize everything. So earlier we used sessions. Sessions had a database overhead, which we wanted to eliminate. So we came to JWT, which was stateless. We had no database overhead, but JWT had a lot of security breaches, and we tried to do everything from encrypting the payload if we were passing sensitive data. When we stopped passing sensitive data, but again, we were getting a lot of attacks and identity thefts. So we worked on some revocation algorithms that included small expiry time blacklisting and like rotating keys a lot. And even after everything was breached, we went to auth0 and auth1 and we talked about all this. So thank you. That was all.